Continuing on with section 3.8, we're on example number 3 now. So we want to represent the function 4 over 1 minus 8x as a power series. All that we're worried about right now is doing the coefficients. That's the same as figuring out what our Taylor series is. So compute the first few coefficients of this series. So first thing that we want to do is find f of x and its first 4 derivatives. So we've got f of x is equal to 4 over 1 minus 8x. Let's rewrite that so it's a little easier to take our derivative. So 4 times 1 minus 8x to the negative 1 power. So first derivative, bring down the negative 1, multiply it by 4, so negative 4. And then we're also going to have this chain rule, so let's go ahead and multiply that negative 8 out in front also. Then times 1 minus 8x, and subtract 1 from the exponent. Simplifying that, we have 32 times 1 minus 8x to the negative 2. Now we need our second derivative, so f double prime of x is equal to 32 times negative 2, which is negative 64. And then remembering our chain rule again, that negative 8, and then 1 minus 8x to the negative 3. So rewriting that, we have 512, so 64 times 8, 512 times 1 minus 8x to the negative 3. So multiply 512 by negative 3 for our third derivative of x, and that is going to equal 12,000, oh wait, not that much yet, so negative 1536 times the chain rule again, so negative 8, and then 1 minus 8x to the negative 4, which then that equals 12,288 times 1 minus 8x to the negative 4. Then we have f to the fourth of x is equal to 12,288 times 1 minus 8x well, let's start that one over again. Let's go back a little bit. So we have the coefficient, then we're going to have to multiply it by negative 4, then also multiply it by negative 8, then by 1 minus 8x to the negative 5th. So that is going to all equal 393,216 times 1 minus 8x to the negative 5. So now we want to use a equals 0. They don't give us an a value here. We're going to use a equals 0 and plug 0 in for each one of these. So we're going to have 0, f of 0 for our first one. If we plug 0 in here, we'll have 1 minus 8 times 0, which is 1. 1 to the negative 1 power is still just 1. So we'll have 4. So f prime of 0 is going to equal 32. So the same thing is going to happen inside the parentheses every time. So 32 for f prime of 0. F double prime of 0 is going to equal 512. F triple prime of 0 is going to equal 12,288. F to the fourth derivative of f of 0 is going to be equal to 393,216. Okay, now I'm going to erase all this rest here so we have, well, maybe we have enough room. Okay, so c sub 0 is going to just equal 4. So this is going to be our coefficient, so now we're including the factorials. So no factorials for the first two. C sub 0 will equal 4. C sub 1 is going to equal 32. And then c sub 2, now we have to start getting into those factorials. It's going to be 512 divided by 2 factorial. C sub 3 is going to equal 12,288 divided by 3 factorial, which would be the same as 6. And then C sub 4 would equal 393,216 divided by 4 factorial, which would be 24. Okay, I'm going to get myself some more room, and then we'll have the simplified version of all that. Okay, so then after simplifying all of those, we'll have z sub 0 is 4, c sub 1 is 32, c sub 2 is 256, c sub 3 is 2,048, c sub 4 is 16,384, and those would be our coefficients for each one of those terms. Now they want to know what the radius of convergence is. We're not going to go into a lot about radius of convergence, but for this one, we can just take our coefficients and do a division. So do c sub 0 over c sub 1, and you'll notice that all of these are the same. So c sub 0 over c sub 1, c sub 1 over c sub 2. So we just have to take a couple of them, make sure that they are all the same. So 4 over 32, 32 over 256. And if you go ahead and do the math with all of those, you'll see that they all equal 1/8. And that will be our radius of convergence in this case. Okay, for this last example, I'm not going to go through and do the whole thing. I've already done a cosine function earlier. What did I do, cosine or sine? I think I did sine. But this one's going to be very similar. It just has 10 inside, so you're going to have to remember your chain rule. We're going to degree of 3, so that means you need to find c sub 0, c sub 1, c sub 2, and c sub 3 for your coefficients, and then build that polynomial up to 3 degrees, a third degree polynomial. So you're going to be entering a function. Now what we know about this cosine and sine functions is that they alternate 0, if you remember back to the example that we did. So it may be that on one of these, and I believe that this is the one, when you have a third degree, you're trying to get a third degree polynomial, well, the degree 3 has 0 as a coefficient. So you really end up having a square, an x squared, or a 2 degree polynomial for your 3 degree polynomial. So just keep that in mind, that when you do end up with that 0 coefficient, we're not going to change anything or do anything different. Just write in what you have as your answer. And your answer is going to be a function. Okay, so you should have 4 terms. Well, if it's a 0, which I'm pretty sure, yeah, this one I guess is just 2 terms because you alternate those 0 coefficients. So I'll let you figure out example 4 and 5, and we'll go from there.